Labor Day edition of my Weather and Climate Office Hours. Thanks for joining me on what for many of you is probably a day off, though perhaps not everybody. I did schedule this one a little bit earlier in the day under the assumption that a lot of folks might be trying to get outside later, especially with the weather as it is today in California, which is to say unusually warm virtually everywhere in the entire state, including all the way to the coast, but not extremely warm in any particular spot either. So that classic Labor Day weekend warmth with a few twists on the classic Labor Day warmth. It's actually a fairly humid heat by coastal California standards. I'll talk a little bit about that. And the other wild cards in terms of the possibility of some thunderstorms in some unusual places over the next 48 hours, and the broader context of this really extreme ridge over the Pacific Northwest and really Western Canada, primarily Western Canada, more so than the Pacific Northwest. That's a bit of a shift from earlier predictions, which will spare the Pacific Northwest a little bit more than we had previously thought, but Western Canada is still squarely in the crosshairs of what looks like is going to be a record-breaking September heat wave. The neighbor has started hammering in the yard, so I'm actually going to quickly just close the window here so that sound doesn't come through. So no birds in the background today. Trade the hammering for the bird song. So I have a dangerous number of tabs open that I want to share with you all today. So I will do so shortly. But I first just wanted to make a couple of brief announcements. One of which is that in the comment section in the live chat, I have pre-posted a survey link to a survey that I developed myself as part of the assessment process within my University of California Agriculture and Natural Resources role to make sure we're reaching the broadest possible audience of Californians. And I've had over 1,000 people fill this out already in the last 72 hours, which is pretty impressive considering I originally released it on the Friday before a holiday weekend. So uncharacteristically, there'll probably be a statistically significant sample of Californians if we can get it well into the four figures. So feel free to fill that out. It would certainly help me out if you did. Feel free to share the link as well with others you know have interacted with my weather and science communication over the years. And we'll wrap that up later this year. But just an internal survey, and I may share some of the results of it if they're interesting in terms of where people are coming from and what their backgrounds are. Probably do something similar every year, so please only fill it out once per calendar year and you'll be in good shape. So thanks for that. The link is right there in the live chat. The other thing I wanted to mention is that later today and tomorrow, so this will be a double header, is that an interview I record with West Marin Community Radio, KWMR, on their Epicenter program will air, I believe, the first portion at 5 p.m. today and the other one, the second half, at 5 p.m. tomorrow. So 5 p.m. on Monday and again 5 p.m. Tuesday, the second half. And will also be archived on their website thereafter, beginning around the same time. And I'm sharing a link to their website today. This is a wide-ranging conversation on a lot of issues that are relevant to California broadly, and then some also that are relevant to West Marin as well. I did grow up in the North Bay, so I have some personal connections there. And there's also a lot going on in West Marin when it comes to the weather and the climate. This summer being a particularly cool one until recently in West Marin, something we talk about in that interview and something I'll touch upon again today in a slightly different context. So I just wanted to make folks aware that that'll be coming out later today. So without further ado, I'm going to start sharing some of my innumerable tabs so I can start to close a few of them so we don't run into any issues. Let's see here. Where is the satellite imagery that I wanted to show? Too many tabs. Far too many tabs. All right, I actually need to open yet one more tab, so we'll see how this goes. It's amazing how tab roulette is still a thing even with modern browsers today. Okay, so I'm going to share my screen now. All right, so what you should be seeing on screen now is a live view from the GOES West geostationary satellite of the Eastern Pacific Ocean and the Western U.S. So a wide frame view. You'll see that that linear sweep going from east to west across the screen. That is essentially the approximate location of astronomical sunrise. So that's where the satellite imagery is transitioning from being infrared satellite overnight, because there is little or no visible light because it's the dark side of the Earth, it transitioning over to visible light once the sun has risen, and when there's enough light from the sun to illuminate the clouds and send that visible signal back into space where the geostationary satellites can see it. And this is kind of an unusual satellite map for September 1st for a number of reasons. And I'll talk about those now. Let me bring up my screen drawing tools, since there's some features here that would be good to call out. And I'm going to change my color since we're in a different scheme now. Let's go with red. That seems like a good contrast with the things that are on screen. So currently what we got is we have a surprisingly robust low pressure system here off the coast, well offshore. With the cyclonic flow that you'd expect. There's showers and thunderstorms swirling the center of this low, which is notable because it's kind of unusual to have such a well-defined, robust, low-pressure system with very cold air aloft this time of year. But then keep in mind, it's a good 1,500 miles west of California on the west coast, and it's not really going to make any more progress closer to the coast. Unlike winter, if this were winter and the jet stream were blowing here like this, this might be a nice bowling ball low moving into California, bringing a significant storm. But it's not winter, and the jet stream doesn't look like that. In fact, the jet stream right now is doing this. It's going off the screen to the north and coming back down in that direction. So we have a jet stream that is going well up and over this low and is not going to push it eastward. It's kind of just sitting there. So we have this impressive, genuinely impressive looking, but quasi-stationary low. It's not really going anywhere. We have another, let's call it a meso low. We'll put ML up here, where we have, again, a little bit of spin in the atmosphere, but it's much less impressive. It's a smaller low-pressure system that's brought some scattered elevated thunderstorms to the Pacific Northwest and British Columbia. So that has already ignited some new wildfires in this vicinity amid the heat wave up there. And then something that I wanted to further illustrate, it's a little bit invisible on this map. There's actually another low pressure system here, but you wouldn't know it by looking at the surface, because right now there are no clouds at mid and upper levels of the atmosphere. All you can see is the marine stratocumulus kind of drifting southward. But I want to transition to a different type of imagery now, and all of a sudden you're going to see this low pressure system. So now we're looking at mid-level moisture in the atmosphere. This offshore low, the big one, still looks pretty impressive. In fact, it looks even more impressive. You can kind of see this one being less impressive, but a little more apparent off the Pacific Northwest coast. And now here's that sneaky little low I was talking about off the California coast. Again, if you look at the little swirl, you still see that there's some nice spin. So all of these are cyclones, low pressure systems, which is what all low pressure systems are technically, cyclones. It doesn't say anything about their actual intensity. But as you can, what I really want to emphasize is there's a pretty complicated flow pattern. Now, what's really going on is there's a gigantic ridge here right now. So this is the ridge, and the jet stream is flying way up north into the Arctic and then diving south. So it's actually kind of cool over, maybe not quite here, but further east off the map in the central U.S. But the key part here is this. This low pressure system, the big one that would actually bring rain, is not going to make it to the coast. This low pressure system, as you can see, it's got some isolated thunderstorms, elevated thunderstorms, not producing a lot of rain. It's kind of moisture starved, but there's enough uplift and instability in the air that it is generating some activity. Now, this low pressure system, the one just southwest of the California coast, is not yet generating, there's literally no clouds associated with it. We saw that on visible imagery. You can't even see this low pressure by looking just at the sky, but it's there. And it's pretty distinct. It's not very strong, but it is making some slow progress toward the central and northern California coast. So we actually expect this low pressure system today and tonight to lift northeastward. The chances are slight, but there is a chance that this low pressure system could fire up some isolated, elevated convection as it moves up along the central coast into northern California. So really, all of central and northern California has a slight chance of some elevated convection later today into tonight. This would likely be in the form of mainly dry thunderstorms, and that is more of a concern now than it was in June, for example, when it was cool. We still had the damp conditions from the winter and spring before it. We've just finally experienced a fairly prolonged heat wave across most of California, so vegetation is now quite dry and would be receptive to any dry lightning strikes. So any dry lightning that does occur later would have a much higher likelihood of starting new fires than lightning earlier this summer did. Now, the other thing that's interesting is that this low pressure system, even as it moves away off the coast of the Pacific Northwest, is still probably going to generate elevated thunderstorms across eastern Washington and British Columbia later today. Given the unusual and record-breaking heat wave that's unfolding up there, that could result in numerous new fire starts. In fact, it already has in the last 48 hours, but there could be yet more. So here are two areas of concern for lightning ignitions, and and tomorrow into the next day that could expand into the Cascades in between. So we actually have a pretty broad region where there's at least a slight chance of elevated convection leading to fire starts. The odds are probably highest up in this region and maybe in Oregon as well, but they're definitely not zero in central and northern California as well. And in California, we can largely blame this sneaky mid-level low. It's not strong, but it's there in exactly the position that historically have resulted in some surprises, and usually at this time of year too. The classic time of year for this exact type of surprise to occur would be probably September or October. The other thing that's going on is we actually have another monsoonal moisture surge. So you can see this is the leading edge of some mid-level moisture moving into Southern California from the southeast. So you see the center of the moisture is moving up into the Arizona Great Basin, but some of it is moving northwestward into California. This mid-level moisture may get picked up in the southerly flow with this weak low pressure system, and that could be the catalyst for that elevated convection later. So we do expect to see more widespread Sierra and desert thunderstorms today and tomorrow as associated with this monsoonal surge. So these storms will be probably wetter thunderstorms. These could produce some heavier downpours, maybe even a flash flood or two. In Southern California, there is a chance that some of these storms are going to make it west of the mountains. These storms could be a mix of wet and dry storms. So isolated thunderstorms even into the LA Basin, San Diego area, could have isolated very heavy downpours, but also could have lightning strikes outside of rain cores and start some fires. And this is what always surprises folks, the highest likelihood of dry lightning is actually going to be farther north and west. So really from this region, from the central coast eastward to the central and southern Sierra foothills, extending maybe even across the Bay Area and the coast ranges to the north. This is where the potential for things to actually be dry and to start new fires in California will be higher. So the odds of lightning in this region are lower, maybe 10 or 20%, but the odds that if it does occur that it would be dry is something like 80, 90%. So low probability but high consequence in central and northern California, including the coast ranges and even the coastal zones in the Central Valley, given the higher likelihood of fire ignitions following heat. So, short version is there is actually a chance of some thunderstorms in all of California's major cities in the next 24 hours. The odds are probably slightly better in San Diego and LA, but there is a slight chance even in the Bay Area, Sacramento, and this other Central Valley cities. So not all of them will probably see lightning, but I would bet that at least one of them probably will, and maybe more than one depending on how this goes. But all thanks to this sneaky low pressure system. And I did want to highlight something. This does show up in our handy National Weather Service Bay Area forecast, which highlights sort of these specific expectation for I guess they're using the same language that I did, a low probability high impact window, or non-zero chances for elevated convection, essentially meaning dry or nearly dry thunderstorms. What I really wanted to highlight is the art of forecasting that goes into this. Numerical models, the predictive models, they historically do a very poor job with elevated convective events in California. It's really difficult to get it right because the difference between a widespread dry lightning outbreak and just some pretty mid-level clouds at sunset is very small and very subtle, and it is not something that is always well represented in models because this is a process that is kind of uncommon in most other parts of the country and is viewed as being either rare or inconsequential when it does happen. So there hasn't been a big focus on improving predictive models, generally speaking, to accommodate these kinds of events. But this is kind of what I wanted to point out, that where the human touch becomes really important. And this is a quote from the Weather Service Bay Area discussion. Even in the nearer term, there is still uncertainty if there'll be convection over our area, so whether there'll be the energy transformations taking place within the 500 millibar wave that the models are unable to resolve properly, ? This time of year, August, September, sometimes October, seemingly innocuous lows will surprisingly spring to life dynamically when least expecting it this time of year. So for the time being, the components for convection do look a bit scattered and displaced from each other, but it bears watching, and there is a non-zero chance for convection. So that's essentially more or less what I was saying, and I think it really just points to the value of having humans with specific local knowledge, because this is not something you'd get from a forecaster necessarily who hasn't spent a lot of Septembers and Octobers looking at California weather, or who is relying directly on model output. I don't think any weather models currently suggest any potential for lightning in the Bay Area. But I agree, and the Weather Service believes that the chances aren't zero later. They're low, but definitely not zero. So if it happens, if it does, what that would mean is that essentially people who have that local context, that local knowledge of pattern recognition, and we've published papers on this, by the way. This is in the peer-reviewed literature. So this human capital is synthesized. It is formalized out there. But it will be something that the best-in-class predictive models didn't catch. And it was pointed out by human forecasters even a day or two in advance. So there are a lot of situations like this still, where if we take the humans out of the loop, we're always going to miss these kinds of events. So in any case, let's see, there was one other, so speaking of this event, potential event, I'm going to take a look now at one of those predictive models that shows some interesting things and does show some lightning potential in unusual places, but not the Bay Area. So let's see what it looks like. This is the simulated satellite imagery. So essentially this is the model's estimation of what the infrared satellite might look like moving forward over the next 48 hours. This is from the HRRR, the HRRR, the High Resolution Rapid Refresh model. As we step forward in time, here is the outlook for, let's stop at about 5 p.m. today. So what you see is mostly clear skies, the entire coastline sunny, so no fog to speak of, really, it looks like. But you start to see some elevated convection maybe developing over the coastal waters in Southern California. So this is that leading edge of that monsoon moisture I mentioned earlier in the satellite. That continues to progress northwestward. So now we're talking about late evening, 8, 9, 10 p.m. This model is suggesting that some elevated convection will develop over the Southern California coastal waters and move inland between LA County, it looks like, and Santa Barbara County, and then inland over the southern Sierra foothills and San Joaquin Valley. As we go through the overnight hours, this sort of expands potentially, in this particular model anyway, across the Central Valley, so the San Joaquin Valley, and then the eastern Sacramento Valley and the western Sierra foothills in the overnight hours. So you kind of see this expands northward and continues into the early morning hours around sunrise or just after sunrise tomorrow, showing some potentially pretty significant convection and maybe even some thunderstorms in the San Joaquin eastern Sacramento Valley. So this would be just along and east of the Highway 99 corridor, maybe even Sacramento area. Some early morning thunderstorms, elevated convection potential tomorrow, extending then up into the northern Sacramento Valley, foothills and mountains as we go later into the morning, into the early afternoon. And then by tomorrow afternoon, we see a more traditional monsoon thunderstorm outbreak across a lot of Southern California and the Sierra Nevada. So the more wetter storms across the deserts and the mountains, transitioning to drier storms the further west you get. Again, fair bit of activity depicted by this model in Southern California, which is why I think the odds of some thunderstorms either Tuesday or Wednesday could be, or I guess this would still be Tuesday, so probably Tuesday, could be pretty substantial in Southern California. And this includes pretty much the whole metro region, San Diego, Orange County, LA County, by later tomorrow especially. So a slight chance overnight tonight, maybe a bigger chance in coastal Southern California tomorrow, before active thunderstorms then continue into Wednesday in the deserts, but maybe become less active elsewhere. What does this potentially look like? Well, here's some simulated radar showing, again, that weak elevated convection. It doesn't look like much on radar, so you look at what's showing up in the Central Valley here. It looks like just isolated showers, sprinkles at most. Doesn't look too impressive there, although tomorrow's potential storms down in Southern California look a bit more so. But look what happens if I turn on the lightning layer, the predicted lightning layer, is you actually do see that there's some lightning first over the Southern California coastal waters and then across the San Joaquin, Central Valley, Western Sierra foothills tomorrow morning. So these would essentially be dry thunderstorms. They're producing only sprinkles, light showers at most, but there's a fairly widespread area of potential lightning in this model. Now again, this particular model doesn't show any lightning in this region. That may or may not end up being true, but there is at least a slight potential for lightning further west. But this is already showing lightning again. This is as far west as Sacramento, so this is already in some slightly unusual areas. And as we head into later into Tuesday, we see that lightning over coastal Southern California in some spots popping up as well. So what is the broader pattern here that we're seeing? It is a weird one. And this is what essentially analysis from earlier this morning. Just trying to get my screen drawing tool back up. There we go. I think I'm going to have to change colors again because this map, I'm going to go a bright pink. Here's that low pressure system, the big one I mentioned earlier, shows up. So actually, they kind of show up nicely on this map. Here's the big low that's not making progress towards the coast. Here's the weak low that brought the isolated thunderstorms to Seattle and Vancouver. And then here's the even weaker low that could still bring some surprises to California later. Here is the broader ridge that I was mentioning. This is the ridge, the peak ridge, and the ridge axis is roughly here. So all of these low pressure systems are evolving under the ridge. They're kind of trapped. The jet stream is going up here and coming down. It's not blowing right into California. So there's not a lot of motivation for these low pressure systems to move quickly. And they're moving kind of erratically. In fact, they're even experiencing what's known as a weak Fujiwara effect, where all three of these low pressure systems are weakly orbiting around a common center. Now, anybody in the astrophysics world will know about the rotation around a common center, where the deeper, or you can kind of think of this low pressure system as a more massive planet, and then this is the second largest planet, and this is maybe some little moon. They're orbiting around a common center, so they're roughly rotating in concert, but the greater influence, as would be the case with a more massive planet with stronger gravitational pull, this low pressure system is influencing the rotation more than these two, and they're actually, this low pressure system is going to try and move back offshore, and this one's going to try and make that loop too. So, and this one won't make it very far east. So it's not exactly gravity, although gravity is there in the mix, but it kind of gives you a sense of how this is going to evolve. So let's actually look at that. If I put away the drawing tool for a moment and step forward in time, here's we go. You can kind of see, there you go, that this low pressure system off of Washington retrogrades to the west, while this tiny little weak low moves into right around the Bay Area by tomorrow morning. Now watch this ridge over the strongest part of the, sorry, that's not a low, I removed that. The strongest part of the ridge over Western Canada, so this is in BC and Yukon territories. This is going to strengthen further. So peak heat has not arrived yet up in Western Canada. So here it is as we get into Wednesday. And as you kind of see, these low pressure systems, the one off of California is kind of just dissolves, but the one that was off the Pacific Northwest coast kind of merges with this larger one off the coast, and they kind of just swirl around each other before becoming one. There's that Fujiwara effect. And as we get later into the week ridging persists over California, so they'll still be warmer than average, but not extreme temperatures in California. Temperatures will continue to be quite extreme, probably breaking all-time September records and maybe all-time autumn records for Canada in BC and Yukon going into Tuesday, Wednesday, Thursday, so for continuing for much of the week. But then that ridge will start to weaken, and one of those low-pressure systems will make a little bit of progress towards California as we get toward next weekend. Now, it does not look like this is going to be capable of producing much, if any, precipitation in California, but it will definitely bring cooler temperatures than we've seen recently and breezier ones. You may notice as we go into next weekend, although weaker, a substantial ridge persists. Sorry, I keep drawing the wrong letter. A significant ridge persists up in Western Canada, and now what we've got is essentially a Rex block. So essentially we have a low pressure system under a blocking ridge, although the flow across the Pacific is pretty weak. In winter, this might have been a good recipe for a major storm pattern in California, but again, it's not winter, we do not have a strong jet stream, and this low pressure system is not going to lead to significant precipitation, but it will bring cooler temperatures, even as Western Canada continues to bake. I'll talk a little bit more about that in a moment. But looking at even further forward than that, going into next week, the low pressure system might kind of sit over Northern California. There could be some isolated mountain thunderstorms from this, but probably that's the extent of precipitation. But again, it'll get rid of the hot inland weather and result in some breezier conditions. That will kind of just fade away in place as this ridge persists once again over Western Canada, and probably before western ridging builds in a little more prominently as we get back toward mid-September. So what does this look like in terms of temperatures at upper levels of the atmosphere? So I'm going to zoom in a little bit because it's a little bit probably small on some folks' screens. What we've got is, we're going back in time to right now, this morning. Look how extremely warm temperatures aloft will become by midweek over British Columbia and eastern Washington. We're talking temperatures that are 20 to 30 degrees Fahrenheit above average in the lower levels of the atmosphere. That's very extreme. Now, obviously, we see warmer than average temperatures across California and much of the rest of the West, but not nearly as extreme as what we've got up in eastern Washington and the interior of British Columbia. This is actually a slightly reduced peak magnitude, by the way, from what it looked like a few days ago, when it looked like places like Seattle and Portland might experience all-time record monthly or seasonal temperatures. Now it just looks merely like a heat wave that probably won't break too many records in Portland and Seattle proper. But along and east of the Cascades, there's actually still a very good chance that all-time monthly records will be broken, and certainly up in BC, which is really the epicenter of this event. And you can see, this peaks with temperatures in interior BC 30 degrees above September averages, which will likely be record-breaking for Canada this time of year. Really extraordinary. You can also see this cold blob downstream, as always. Dipole patterns exist, but the magnitude of the extreme warmth, as we continually see in a warming world almost always, is greater than the peak magnitude on the other side of the dipole of anomalous coolness across the central U.S. And you can already see by midweek this upper level warmth across central California is already fading, although it's still there in the far northern and the southern part of the state. And you can see that this persistent pattern, this dipole, continues later into the week with extreme warmth persisting across British Columbia and parts of Washington. But coolness now is slightly cooler than average air mass by next weekend at lower levels into California. Not remarkably cold, but a big change from the above average conditions we've seen recently. So this is at upper levels of the atmosphere. What does it look like at the surface, which is what we actually care about? It's where we live. Well, you can see, again, going back in time to now, stepping forward a little bit, we go into Tuesday. It looks very hot still across even the interior of California, but really the epicenter here again is, if you just look at the magnitude of that warmth over British Columbia, it's just staggering for September. And then you can kind of see California cooling down as we go into next weekend, with cooler temperatures, especially relative to recent days, but really warm temperatures continuing western Canada. And then if we smooth this out a little bit, if we go to 5-day moving averages, it's a little bit easier to see. Next 5 days, warmer than average across all the West Coast, but then cooling in California by next weekend, staying warm in the Pacific Northwest and Western Canada, and then cooling off, but before maybe warming up again a little bit in California as we go toward mid-September, although there's significant uncertainty with the flow pattern there. Notably, though, Western Canada stays hot this whole time. The signal fades a little bit, but it stays pretty darn warm through that period. The other thing I wanted to show is just how warm the nearshore ocean temperatures have become off the coast of California in recent days. So in great contrast, earlier in the season when there was cooler than average water along essentially the entire California coast, now we have the reverse. We have warmer than average water along essentially the entire California coast, and there are blobs in different regions of well above average. So near the Channel Islands, we're talking about, I guess the scale is cut off here. Let me scroll down slightly so you can see it. This is in degrees centigrade. 2 to 3 degrees centigrade is about 5 degrees Fahrenheit warmer than average. Santa Barbara, the Channel Islands, off of Malibu, but also now off of Cape Mendocino. In fact, maybe even a little bit warmer, 5 or 6 degrees Fahrenheit warmer than average off of Cape Mendocino. That is very noticeable. But even off the Bay Area, a couple of degrees warmer than usual as well. So the immediate coastal areas now are a lot balmier than they were earlier this summer. I've already heard lots of folks remarking on this, and this may continue for a while because we don't really expect to see a big increase in the upwelling in the coming weeks. So this may keep the coastal areas warmer during the relatively cooler pattern than they had been earlier in the summer, where the coast was really cool and inland areas were warmer. We're going to see less of a gradient now with these warmer nearshore temperatures. And again, a lot of folks have said, well, but doesn't the coast always get warmer in September relative to earlier in the summer when the fog is more prevalent? Yes, that is true. But what this is showing is that it is unusual even relative to the typical seasonal progression. So this is not just your average ocean temperature warming as you go into September. This is a more sudden and more substantial warming than would be usual, even given that it usually does warm up in September relative to earlier in the year. And the main reason for this is you can kind of see that I'm talking about this narrow strip along the coast since we care about it a lot from a practical perspective in California. But look at this enormous blob north of Hawaii of extremely warm water, just contiguously warm water, no interruptions at all. There's actually, in many cases, a lot warmer well out in the ocean than it is right along the coast. Hold that thought in mind, because now I want to zoom out. Here's the global version of this, and there's some really amazing warmth right now. The whole North Pacific Ocean is now experiencing, I think it's fair to call it, an extreme marine heat wave. This is likely breaking records. In fact, we know it's breaking records in some regions. The entire North Pacific, all the way from the coast of South Korea and China, and especially surrounding Japan. I mean, look at some of those values. All the way eastward to California. In fact, except for this relatively narrow swath south and east of Hawaii, if you look essentially from the equator northward in the Pacific, any small patch of cool water is definitely the exception relative to the norm. But if we look essentially only at the Pacific north of 30 North, which is essentially the subtropics to the Arctic, there is not a single region of below average temperatures. In fact, the entire region is much warmer than average. This is a really remarkably extreme, record-breaking marine heat wave, and it's resulted in some pretty extreme impacts in the ocean itself that are as yet untold, but also in Japan. Now, this really warm water did not extend all the way to the California coast until recently. For most of the summer, a cool blob remained right along the coast, but that is now gone, and I think people are noticing it out of the beach today. But what's going on in Japan has been persistent now for months, and if we look at what that has meant in practice, here's a snapshot from Twitter, or X now, from somebody who has plotted from the Japan Meteorological Agency the long-term temperature trend in summer. Obviously, Japan has had a really sustained warming trend over time, but look at this year's value relative to all previous values. This is a record-shattering event. In fact, last year was also record-shattering, but now this year shattered last year's record-shattering record. And I don't use the term record-shattering lightly, by the way. What I mean is not just that it was the highest value in the time series, not that this just was the single record value, but that it broke the previous record by an incredibly wide margin. That's what record shattering is intended to connote. It's not some term in the meteorology world or the climate science world that we use just to be hyperbolic. It actually does have quantitative meaning beyond just record breaking. Record breaking could have been, say, if this year was right here, just above the previous record. That would still be remarkable given how high last year's record was above the previous record value. But this to this is a record-shattering jump, and then again, this to this is another one, because that's breaking the previous record for the entire summer for the entire country by almost an entire degree. Actually, it is a full degree Fahrenheit, which is a major accomplishment for a seasonal anomaly for an entire country. This is not dissimilar from the record-shattering heat that California saw earlier this decade. Not this summer, of course, but earlier this. And now we're kind of just floating around near the top of the time series. But Japan, with this record-breaking marine heat wave, is seeing a truly extraordinary level of heat and extreme precipitation this summer. As are adjacent regions, as I mentioned, South Korea, as well as parts of eastern China. So shifting gears slightly to wildfire, I did want to jump to probably the most consequential fire currently burning in California, which is the Garnet Fire on the western slope of the Sierra Nevada. It's now well above 20,000 acres, so this is one of the larger fires this year so far in California, and it yesterday burned into the Tea Kettle Experimental Forest, which, as if those of you who are knowledgeable about the area or the state of fire and fire science and ecology in California know, this is a fairly important installation, actually intended to study the effect of different forest treatments, from forest thinning to prescribed fire, in terms of what the after effects are when a fire moves through. Now, this does mean, unfortunately, that it does appear that the tea kettle experimental forest has either mostly or completely burned now as of this morning in this fire, or if it hasn't, it likely will today under already very active morning burning conditions. And it probably did so or will do so under pretty high intensity. So this will not be a low to medium intensity burn. This will likely be a high intensity fire moving into the tea kettle experimental forest today, if it hasn't done so already, which some folks have lamented because not all of the proposed treatments were completed in this experimental plot. So now we're going to burn it out without having the full opportunity to learn. But there are experiments now that will get their real test. This is the test, ultimately, of what is going to happen when a real wildfire burns with pretty high intensity through different forest plots that have been treated in different ways, with different combinations of thinning and prescribed fire and thinning following fire or vice versa. So I do think we're going to learn some important things about different forest treatments and their ability to alter fire severity in this type of setting, which is probably the silver lining to put on this. But the not so silver lining is that this is threatening important PG&E infrastructure and will likely go on to burn a lot more land. I would be fairly surprised if this fire has yet reached even half of its final footprint, given that we're going to see potentially major plume-dominated, even pyrocumulonimbus fire activity in the coming days, strong thunderstorm outflows, and continued heat in this region. It's been very dry and hot here recently, and we're seeing extreme fire behavior, sustained crown runs, and fire-generated plumes of smoke that go on to reach 20, 30,000 feet in the atmosphere and effectively become their own thunderstorms. So there are evacuations in effect, although this is mostly for low or no populated areas, although recently the evacuation warnings at least have extended all the way to the eastern side of Pine Flat Lake, where there are some structures, and you can kind of see there's not a lot stopping this from burning into the wilderness, except for eventually you get up into the granite. So it's, that's a substantial impediment to fire spread because there's just little or no vegetation once you get up to the highest elevations in the Sierra. But there is a good chance this fire is going to burn all the way into the granite, into the wilderness, the John Muir Wilderness. The real concern, honestly, is spread in the northwesterly direction, kind of parallel to the topography, because this is a direction where there's not really any recent fire history, so there's a lot of fuel to burn. It's been very dry, and it's going to be difficult to control it given prevailing south to north winds a lot of the time when there's not a major wind event. This fire has wanted to move west and northwest, and it will likely continue to do so. So there is some pretty significant potential for spread still in this direction, and that could cause problems down the line. If this fire is still burning in a few weeks, by the way, if there's a major offshore wind event and it's made some progress up here, it could make a big run to the southwest and potentially affect places like Pine Flat Lake at that time. So this is a big fire that looks like it's going to be burning for weeks to come, and it could, depending on how things go, could be a big story. But the story today is it's burning directly into the tea kettle experimental forest, which is, it's going to give us some data, but it's also probably going to, given what it did yesterday, it's going to kind of nuke through there at pretty high intensity. So we'll see what data is gleanable. Hopefully it's just not that they all burned at equivalently high intensity, because that will be a little bit sad if that's the case. But in any case, that's probably the most consequential fire. It's not the only one. No major fires currently active in Southern California, which is a bit remarkable. We'll see if that holds today with some lightning potential ignitions. A bunch of fires recently started up in northern Napa and Lake County. The Pickett fire was the most significant, but that's largely been handled. There's not much heat, if any, left on the Pickett fire, and people have been allowed back, so the evacuation orders are done. There's still a few warnings, but they're mainly precautionary. A couple of good catches up in Lake County, the Peter Fire, the Scott Fire, the Elk Fire, all could have gone pretty big. But right now, because there is high availability of air resources to really drop a lot of retardant and water on these in their early stages, there have been a lot of quick catches. And, There is this ongoing debate, by the way, about whether it's always good that we catch all of these fires when they're small under sort of more moderate burning conditions. On the one hand, you don't want any of these fires to go on to threaten people's homes. But on the other hand, if we don't have these fires and if we don't scale up or prescribe burning in some of these ecosystems greatly, then we're just sort of prolonging the inevitable and increasing the odds that these areas end up burning under high severity conditions, like a major offshore wind event during an extreme drought. And we don't have any of those things in this region right now. So it's tricky. It's not an easy calculus. And some of the fires that are burning, for example, up in northwestern California right now, and there are quite a few, are probably doing a pretty good mix of, producing a good mix of benefits in all likelihood, at least under current burning conditions. So we do have a couple of big ones. There are some evacuations in effect. The Dillon fire is the largest, but the Blue Fire has been expanding. And the Blue Fire in particular is expanding relatively close to Happy Camp, so no evacuations for Happy Camp proper now, but there are some warnings that are getting close to town. And a pretty broad region of evacuations surrounding the Dillon fire because, frankly, it's in a pretty remote area and has a lot of room to roam. But there are a few others. There's the Log Fire, which is expanding. There's the Peak Fire, the Lick Fire in the Shasta Trinity Forest. All of these are modest in size, but burning in heavy timber in remote places. And so they likely, under current hot, dry conditions with a fire weather watch in effect right now for potential dry lightning later, lightning and strong gusty winds, these potentially have a lot of room to grow. Arguably, a lot of these, what they're burning right now, are places that are then not going to burn under higher severity conditions, not during a severe drought, not during a major wind event. But one risk now is that as these fires expand, they're unlikely to be extinguished in the next couple of weeks, and that does bring us into strong wind season before the rains arrive. So if we do get a major wind event, an east wind event, before substantial September rain, and I'll say right now, there is no indication currently of substantial September rain in the first half of the month for Northern California, then these are the kinds of fires that can kind of skunk around for a few weeks and then really blow up under a wind event. So that is going to be something to watch. Similarly, we don't have too many fires right now in the Northern Sierra, but there are a couple. The Springs Fire popped up last night. There were some local evacuations. You can still see in the live camera view right now, it is still burning, but it's not doing too much. I'm guessing they'll probably get a handle on this one before it goes too much further. That's my guess, because again, we don't have extreme wind conditions right now. But I would expect to see new ignitions later today, tonight into tomorrow. So we're just going to have to see how that evolves with the dry lightning in the forecast. Further north in Oregon, we do have major fires burning. The really prominent one is the Emigrant Fire, which is now over 20,000 acres, burning again in heavy forest, dense forest in the Cascades. That's going to get a lot bigger under the hot, dry, windy, and maybe stormy conditions. And we've seen a few others pop up. These are significant fires because a lot of them are burning in heavy forest. So the Hungry Fire, 4,000 acre fire burning again in heavy timber, the Wildcat Fire in Washington, heavy timber, and all of these fires along the crest of the Cascades, these are all lightning ignited, or most of them, and they're likely going to blow up. So this is a big major fire story in the Cascades because very hot conditions, very dry conditions, and potentially some dry lightning up here in the coming days. No wetting rain to speak of, just heat, lightning, and maybe some wind. Again, watch duty doesn't go up into Canada, but if you saw it, there's a lot of new active fires up in BC, including some on Vancouver Island, which again, doesn't see fires with the same frequency. So there is an unusual level of Canadian fire activity. And just to highlight that, I'm bringing up the Canadian map here. Excuse the French, literally, in this case. But what we've got here is unusually high fire risk across a lot of Western Canada right now going into this week. It is not usual for September to have extreme fire risk in not just in the Northwestern Territories, but across most of BC and most of Alberta. The rainy season usually arrives early up there. Winter comes early in Canada compared to the US, but especially compared to California. So it is pretty remarkable to have most of Western Canada, I'm sort of outlining the area, that's either very high or extreme fire risk. This is already the second largest area burned in Canadian history this year, second only to the unbelievable, again, record-shattering season of 2023. We're going to add to those numbers this week. Hopefully there's no major fires of consequence to communities, but there's already large-scale evacuations up in the Northwestern Territories of populated areas. And again, this is very unusual for this late in the season up there. I think this portends a potential big surge, one last big surge in Western Canadian fire activity in the coming days. And as you can see in Canada, this year, we're, way above. I mean, this is the 10-year average, which has already been increasing over time, and this 10-year average includes the exceptional year of 2023. So we are way, way above that already, and we're going to probably end up somewhere up here, even further above. Okay, so I think I'm going to stop sharing my screen now because it would be good to answer some questions. A lot of folks joining on a Monday morning, a holiday weekend, so thanks for being here. For those who missed it, just a reminder that ideally when you're done with this session, there is a survey that I've shared from University of California that's helping us to assess our reach in my weather and climate communication activities. Feel free to fill that out if you've got a moment. Probably take you less than 5 minutes. Pretty basic demographic information. But I'm going to go through and look at the questions and maybe even answer some of them. Oh, and the other disclaimer is that I am in fact not a robot. I do exist. I am not an AI figment of your or anyone else's imagination. So far as I am aware, I suppose the possibility is there that we've reached AGI, and I don't know that, in fact, for the last 20 years of the California weather blog, or Weather West in its current iteration, I have in fact been advanced artificial intelligence since long before it was widely known and understood in the world. But anyway, I raise this because I've been starting to have some problems with folks who've been reaching out skeptical that the Weather West channel is real and that I am a real human being with domain-specific knowledge in weather, climate, and wildfire. Was recently applying for a visa electronically and was also rejected because my face apparently did not look like a real human being. So, we're living in an interesting world, but I assure you that I am real and that none of the content on this channel is AI in origin. That should probably be obvious due to all the technical flaws that you see if you look even slightly closely. But in any case, whether that's reassuring or not, whether that's edifying or not, I did want to make the public statement that I am, in fact, real. Okay, all right, so question-wise, what do we got? Yeah, I mean, I think Mary and others have mentioned about the either figurative or, in some cases, literal post-traumatic stress associated with dry lightning. And, I always do like to emphasize that what happened in 2020 was really the very upper end of how bad things can get with dry lightning. It was a really spectacularly extreme dry lightning event in places like the Bay Area, and it coincided with the worst drought on record. So extreme dryness, extreme lightning. Right now, we neither have an extreme drought nor are expecting extreme lightning. So as always, it's a matter of degrees. And, things are dry. They're definitely drier than they were back in June when there was that dry lightning threat. But the risk is higher. It is genuinely higher. But the ambient burning conditions are not as extreme, nearly, as they were in 2020. And the volume of lightning would likely be a lot lower. So, and also, resource availability for now is higher than it was. That may or may not continue to be the case as we start to lose some of the seasonal firefighters with the Forest Service due to the time of year. They're seasonal, they're not year-round. And as we have an unusually late peak in some fire activity up in the Pacific Northwest, right as California enters what could potentially be, in some parts of the state, peak fire season over the next month or so. But it's all relative. There might not be any lightning in the Bay Area. In fact, the most likely outcome, if I had to pick one, is no lightning in the Bay Area. But there probably will be some dry lightning elsewhere in California overnight into tomorrow. And And there is a chance that there could be some along the coast and even in the Bay Area, although that chance is modest at the moment. All right, some West Marin representation, it looks like, in the comment section today. Yeah, Professor H mentions that there's no mention of lightning in the official Weather Service forecast for Modesto. That does happen, and sometimes if the odds are perceived to be below 20%, it might actually be in the forecast but unmentionable. So in the text-based forecast, things that have under 10% likelihood usually don't show up at all. This is something you can only glean from looking at the forecast discussion or consulting folks like myself, I suppose, is the other option. But it is possible. The odds are low, but it might happen tonight. Don't be too surprised if you wake up to some flashes or some rumbles, even in places like Modesto. Yeah, Patrick mentions up in the Pacific Northwest, done with the heat, bring on the fall rains. I wish I could say they were imminent, but it doesn't look like they are. Again, Seattle, Portland don't look like they're going to be super extremely hot with this event, but they will definitely be much warmer than average, and the inland regions from the Cascades eastward genuinely may hit all-time monthly records in the coming days. So this will still be an extreme event, just not quite the widespread record-breaking event that it looked like it might be a few days ago, which I think is a good thing. We don't really want to break those records right now. Yeah, as a comment from Mary, I mentioned the big fire up in the Northwest Territories, which again is very unusual for this late season. Winter arrives, or at least it used to arrive, often in September. That far in the, you're up in the subarctic there. Not this year though, apparently. Question from Marilyn about what the weather pattern, the complex one earlier, and whether that's related to global warming or the weakening of the Arctic sea ice. It's a really difficult question to answer. There is no straightforward answer to that. And there are potentially different ingredients in there that are relevant. That extreme North Pacific heat wave, for example, that is probably influencing that really weird-looking low-pressure system, which in turn, that low-pressure system is partly what helped to generate, through latent heat release into the atmosphere, the extreme and record-breaking upstream ridge. So the SSTs can lead to the low pressure, which can lead to the high pressure, which is sort of a Rube Goldberg-style concatenation of causality. The Arctic sea ice loss we've seen, the Arctic amplification, there is some evidence this is potentially having a significant influence on North Pacific circulation, specifically in autumn. So we're now just entering autumn. The answer is, there might be some influence there. I think the primary answer is no, that's not the main reason why things are happening in this weird pattern. This is just kind of a randomly chaotic weather pattern. But there are some pieces to it that if you add them up, maybe aren't so insignificant. So the real answer is that there's really never any way to discern that without doing a formal study. But the way I see it, the most obvious climate change connection is with the record-breaking North Pacific marine heat wave that I mentioned, which clearly is influencing the propensity of these low-pressure systems to develop thunderstorms, and downstream, in some cases, the stronger the low upstream, the stronger the high downstream, and that's kind of what we're seeing across the Pacific Northwest with this extreme blocking pattern. So in a highly nonlinear complex system, it's difficult for human mere mortals to sort of work your way through the chain of events, and so I won't try and do so more than I just did, except to say there could be some links there, but it's usually not the main thing at work. But then again, I've been surprised. Question from Mary about ENSO. I'll talk about El Nino, or the lack thereof, more likely La Nina this year, in a forthcoming blog post. There's a mention that the news media will never talk about the specific heating. I'm not quite sure that's true, although I haven't personally seen any major headline news stories about it, even though it is definitely a headline level climate event, I think. Now, there's certainly been news in Japan domestically about how record-breakingly hot and wet it has been, so indirectly, and I think some of those have mentioned the record warm ocean, but it might become more of a story going into this fall. There's an interesting question about whether the kind of influence that record warmth in the Pacific would have for winter conditions in California and the West Coast. Well, the most obvious answer, obviously, is to the extent that it persists, and it might, it would make for warmer conditions, particularly in winter when we don't have as much coastal upwelling, and when stronger west to east winds blow that warmer marine influence further inland. It could juice up individual storms, so you can produce stronger low-pressure systems through increased latent heat release and moisture atmospheric rivers, which you might think would increase precipitation, but it can also shift the storm track to the north and weaken the jet stream. So you get a juicy, moisture atmosphere, warmer atmosphere, but you potentially simultaneously get an atmosphere that's less conducive to producing the storms that you'd need to squeeze out that moisture to begin with. So two very different and counteracting effects. Higher ceiling, but potentially lower likelihood for winter storms. Kind of sounds like a familiar flavor in a warming climate. At least that's what I think, as a climate scientist who studies California weather. How is this blob affecting marine life? Well, likely substantially, and given that it's been sustained for so long, it's probably not great news for offshore ecosystems in particular. One question is always how deep the warm water extends. There's a lot of the ocean's life is at the surface, but of course not all of it. I don't know yet. The last time we had a really persistent North Pacific marine heat wave, it was pretty devastating to a lot of ecosystems, marine ecosystems, and we'll just have to see how this one plays out, especially now that it's moved closer to the coast. Previously, there was no marine heat wave along the Northern California immediate coastline earlier this summer. In fact, it was actually chilly. The marine life was probably doing really well. Increased upwelling, more nutrients, cool water. So at least there's that reprieve. Now, as we get much warmer water, that transition might be a bit of a shock. And of course, warmer water along the Farallon Islands, for example, is all relative. Warmer means like maybe low 60s Fahrenheit if we're lucky, which again is pretty warm for the Farallons, but it's not warm relative to the 75 degree water off of Malibu currently, for example. So it's all relative. Jim mentions that they are catching marlin off of Oregon and Washington, and that's likely because even though the immediate nearshore waters weren't super warm until recently, you only had to go 50 or 100 miles offshore, which presumably the marlin are not hugging the immediate coastline, to have much warmer water all summer. So that is something that has been developing for a while now. So there's a comment from Marilyn about talking about despite some of the objectively nice weather in the Bay Area and recent places in recent days, weeks, months, depending on your preference, you can kind of probably find a nice window of weather this summer in San Francisco because we've had the full range of temperatures. Is global warming accelerating according to predictions, or is it slower? And I do think that to this end, I think it might be helpful for me to reshare a link a video that I produced a little bit earlier in the summer, just a few weeks ago. And I've shared it during a previous live stream, but I'm sharing it again now in the comments at the end. So this won't come right after Marilyn's comment, but it's going to come in the very end of the comment section here. But my thoughts on where we are today, a month ago, but global warming-wise, we're about the same place a month ago as we are today, and what that means in the broader context. Global warming, the rate of warming globally has increased a bit recently, although it was predicted to increase a bit roughly around now. We're still working out exactly whether that bit is maybe a bit larger than predicted or not, but in any case, it's not greatly faster than expected. Unfortunately, warming was expected to, on our predicted trajectory, accelerate a little bit right around now, and it appears to have done so. And that's not great news. It's also not unexpected news. Not necessarily worse than expected news in any large-scale sense. Now, are there pieces of the system that are evolving in a worse than expected way? I think that's true, but it's not necessarily that the overall amount of warming is much worse or much faster than expected. So I get into some of the details there. You might find it helpful. If not, let's return to this in a future session. Feel free to ask some additional questions, although I'm realizing I'm already running into bonus time this hour, and some folks probably want to get outside. So I'm going to try and wrap up these questions in the next few minutes here. So a few good ocean dynamics questions I won't have time to get to today. Yeah, several folks have called out Zeke Lunder's The Lookout as a good source for wildfire information, and I agree. He has a really good local knowledge of lots of California's geographies and fire ecologies. Let's see. And they are diverse, by the way. That I used plurals there on purpose because very different logic and history applies to, say, the Southern California chaparral than is true in the southern Sierra for conifers, or versus the coast redwoods in Santa Cruz County or up in Del Norte, up on the North Coast. So it is important to have that local knowledge and to be specific about what ecosystems you're talking about, what the fire histories are or aren't, and what the response of different ecosystems is to fire. It is ecosystem dependent. It depends on history. It depends on what plants are there. It also depends on the weather and the climate. And obviously the climate is changing, and so it's a moving target. Things are, they ain't what they used to be, both in that respect and in so many others. More complicated conversation perhaps for a longer day, a longer different session. A lot of late comments, so I'm trying to get through them here too. A question: if the entire Pacific Ocean for the most part is well above average, warmer than average presumably, does that mean we have major upwelling deficit, or in deep ocean waters also warming up? So that big red-orange blob I showed, it's all surface temperature unusual warmth. What that means is that there is an accumulation of heat at the very surface layer of the ocean that is unusual. What happens, so when we get winter storms, that's going to start to mix that unusually warm water as the ocean waves pick up with the deeper levels. So that's going to mix some of that global warming, essentially, deeper into the ocean. So when that map starts to cool down later this year, once the storms start churning up the ocean, it's going to mean that the surface waters get closer to average, but it's going to mean that the turbulent motions of the atmosphere and ocean have diffused some of that surface warming to deeper levels. And what we do see is that ocean heat content, and including ocean warmth at lower levels, is rapidly increasing. So this is why, for example, when a hurricane comes along and goes through, unusually warm water in the Atlantic or something, and you see this cold wake behind it. Behind the hurricane, the ocean is now cooler than average. People say, great, the storm ate up a bunch of energy. Now it got rid of all that extra warm water. Well, it got rid of it in a local and transient sense, but what did it actually do with all that excess heat? Well, it transformed some of it into the strength of the storm itself, because hurricanes derive their energy from these warm oceans. And some of that energy is getting added back into the atmosphere, actually, in the form of latent heating, so the evaporation of water, and that can actually result in major terrestrial or oceanic atmospheric heat waves in adjacent regions. Some of that warmer water is getting mixed to deeper layers of the ocean as the hurricane churns up the water. So the really warm lens of water at the surface might be dissipated, but some of that warmth got mixed into the deeper ocean, and some of it is getting redirected poleward. So there'll be a pulse of Arctic warmth in the wake of a big hurricane, because hurricanes exist largely to move excess energy in the tropics to the polar regions. So you're redistributing the energy, but a lot of it is remaining in the system. And it's not always long-term good news when those surface temperature anomalies at the surface of the ocean decrease, because a lot of the time you're either then adding that energy back into the atmosphere in terms of more evaporation or warmer air, latent or sensible heating, respectively, or you're mixing it through turbulent oceanic water motion into the deeper ocean, where it's going to stick around for centuries to millennia. And that is why the deeper ocean is warming as well. It's a good question. Well, people joke about being able to pass the robot AI CAPTCHA humanity tests, and like that you see, like, you know, which of these photos has trees or which of these photos has stoplights. But recently, I've failed a number of these, so maybe that's telling me something. I don't know. Hey, Mike Flanagan, on the in the chat today. Nice to see you. Mike, who is a Canadian wildfire expert and fire weather expert in particular, points out that on average we should be expecting around 2 or 4 fires per 100 flashes for this time of year. I'm not sure if that's sort of a Canadian boreal forest number or a Western U.S. number. If it's a Canadian number, I'd expect the number in the Western U.S. to be a bit higher, because we have very responsive vegetation in early September. It's very dry. But even then, even if we assume 2 to 4 lightning ignitions per 100, presumably cloud to ground strikes, for perspective, in recent days we've seen tens of thousands of lightning strikes across the western U.S., and we might see tens of thousands more across the western U.S. and western Canada in the coming days. So that is a lot of potential ignitions. And I would expect, especially up in Western Canada and cascades eastward, during this potentially record-breaking heat wave this coming week, that we'd at least be at the upper end of that range, so closer to 4 ignitions per 100 strikes versus 2. So really 1 in 25 lightning strikes starting potentially a fire. Not all those fires will go on to become large or consequential. Some of them will burn a single tree or a snag somewhere and self-extinguish or be put out by some strategic helicopter bucket work. But once you start getting hundreds of individual ignitions, you can't do that with all of them. And again, there's the question of whether we want to be doing that with all of them, because some of these lightning ignitions in some spots are going to be putting, it's kind of like what prescribed fire folks might call involuntary initial entry, where you sort of, it's difficult to reintroduce fires for any number of practical and political reasons in places that have a natural fire deficit over the past century or so. Sometimes lightning forces the issue, and because we can't prevent the lightning, it brings fire to those places that need it. So again, it's a risk-benefit balancing proposition. Some of those fires will go on to do needed good fire work in remote places where we've seen a deficit of natural fire, and then some of them might go on to either cause problems because they're in more populated areas, or go on to cause problems later because they're initially doing good work, skunking around in the underbrush for a week or two, and then we get a major wind event potentially, and they blow out later. So and this is really the big concern, honestly, is that in the Pacific Northwest especially, but also parts of Northern California, but especially in Western Canada, the sequence of elevated heat, which all of these places have now had in recent days or ongoing if you're in the Pacific Northwest or Canada, followed by lightning, which a lot of these places may get in the next 48 to 72 hours, especially dry or nearly dry lightning, and then followed by at least the potential for a wind event. Now, we don't see any major wind events on the horizon right now, but we also don't see any major widespread wetting precipitation events in this region, which means that any fires that ignite during this potential lightning bust, as they're called, will likely still be burning for now when the first wind event of the fall arrives, unless there's an interceding precipitation event. Right now, I don't see that. So there is a risk that fires that start now could burn for a couple of weeks and still be burning, especially in some of these more remote forested regions, when a significant wind event may or may not come. before the rains. So it's often a race between the seasonal onset of rains and the seasonal onset of east wind events along the western coast of North America. There is an increased likelihood this year that the winds beat the rains, and that we'll have a lot of lightning-ignited ignitions in remote places before that happens. So there is that potential. We could short-circuit all of it with a well-timed atmospheric river in the next few weeks, but right now it looks unlikely in all of these places that would really benefit from it. Best case scenario is that we ignite a bunch of fires this week with lightning in places that need to have a fire deficit, and then in a week or so, a lot of those fires got mitigated or extinguished by rain. Right now, it doesn't look particularly likely, but could surprise me. Yeah, Mike also mentions the last few years we have been seeing fires burning into September in the Northwest Territories. I mean that's a pretty clear climate change signal, as Mike knows. I mean, that lengthening of the season, particularly in places that historically would have seen relatively early onset, to seasonal precipitation. I mean, Northwest Territories, sometimes it's snowing by the time you get to mid-September even, but it's not going to happen every year, by the way. Last year was not a very active fire season in a lot of Canada compared to 2023, certainly, or even compared to average. But what we're seeing is not so much that the quiet years are getting more active in places like Canada, but we're actually seeing that the extreme years are becoming far more extreme. And so we see this widening range, increasing wildfire whiplash. We still have really quiet years in between, but then the not quiet years are extremely unquiet years, and we just are continuing to see that pattern evolve in so many different spaces in the weather, climate, and wildfire world, and in different regions too. Similar in California. Look at our 2024 fire statistics in California, or especially 2023. Nothing too impressive, fortunately. 2024, though, immediately started out the year with some terrible fires in Southern California, and we'll see what happens the rest of the season up north. It's a question about whether this blob, presumably the warmth in the North Pacific, is different from the blobs that led to the long-lasting drought in the 2010s. There is still an ongoing debate the degree to which the blob caused the drought versus the vice versa. I think the preponderance of evidence shows that the roughly circular region of unusually warm water in the North Pacific in the 2010s that coincided with the ridiculously resilient ridge years, if you remember those, were likely a result of the ridge and not a cause of the ridge, although at some point there is some self-reinforcement. So did they make the ridge more ridiculously resilient than they would have been? I think that's possible, but it's unlikely it caused the ridge in the first place. More likely is that this persistent tropical ocean temperature anomalies in the West Pacific kind of indirectly forced that ridge to just constantly recur in the same place, which then caused the North Pacific to warm up, which maybe made the ridge even a bit more persistent and consequential. This is a bit different, though. This is a similar magnitude of anomaly, but over a vastly broader region, all the way, as I mentioned, from the Koreas and Japan to California and northern Mexico. So it's a much broader region, and what that means is instead of being sort of this isolated pocket of really warm water, the whole North Pacific is extremely warm. But the subtropical Pacific, near south of Hawaii, is not so warm. So think of what temperatures in the Pacific would normally do. They get cooler as you go north. The ocean near Alaska is cooler than the ocean near Hawaii, right? That's not too surprising. But what this year is doing, because the North Pacific is so anomalously warm relative to its typical level, and the ocean, the subtropics near Hawaii, is not that anomalously warm, it decreases the gradient. So the cold ocean up north has warmed a lot, and the warm ocean in the south has warmed almost not at all. What that means is that the meridional, the north-south temperature differential, or the gradient, is a lot weaker than usual across the entire North Pacific. Now, that gradient, the ocean temperature gradient and the air temperature gradient above it, because they're related, is partly what drives the strength and position of the Pacific jet stream. That's going to come into play this winter. It might mean there's a weaker than usual jet stream. because that gradient is not nearly as strong as it would normally be. It also might mean that it's shifted farther to the north. This could compound the effect of a La Nina event. In fact, it might make the weather patterns this winter look a lot more like La Nina, even if we have a pretty marginal La Nina event. It might make this La Nina event, if it occurs, have outsized effects. Even if there is no official La Nina, even if it's a neutral ENSO year, the atmosphere might behave an awful lot like a strong La Nina event this winter, especially from the perspective of California, because of this shift. I'll talk more about that in a later session. A lot of comments today, a lot of engagement, so thanks for joining. By the way, it's always great if you subscribe to the channel, helps get the viewership up, and we've seen a pretty large increase in the number of channel members recently, or subscribers. I'm using those terms interchangeably, I forget which is which. But in any case, if you want to be notified when these live sessions occur, sometimes on short notice, the best way is to subscribe and turn those notifications on. There's a question about whether we can expect more haze and smoke alert days in the northern, midwestern, and eastern parts of the U.S. because of continuing extreme heat and fire risk in Quebec. Things may shift a bit. There's going to be drift smoke from western Canada, probably in the western U.S. at least, although it's more distant smoke, so it'll probably be less dense and less close to the surface. In a general, multi-decadal context, should the middle, central, and eastern U.S. expect more smoke coming from Canada? Probably. That's certainly been the trend in recent years, and I don't really see it reversing. Although, as I mentioned, Canada's fire season is often highly variable. You still get really quiet years that are wet, cool, maybe not so cool, but wet anyway, where you don't get a lot of area burned. And those will be the years where there won't be as much smoke in the central and eastern U.S., but you'll get these extreme years, and this is another extreme one, where you're going to see a lot of days, sometimes weeks on end, where you get that smoke in the central and eastern U.S. So Mike clarified that the flash rate conversion was a California-specific number. So Canada is actually closer to 1 in 100. So boreal forests in general, 1 in 1,000 flashes. So that does account for the fact that the likelihood is per lightning strike is higher, much higher, like an order of magnitude or so higher in California than it is in other places. Then again, you get a lot more lightning in the boreal forest. So even if 1 in 1,000 strikes starts a fire in the boreal forest, in an active week, it's certainly possible to get 50,000 lightning strikes. So you could easily get a few dozen fires from an active thunderstorm week in the boreal forest. Now in California, it's harder to get those tens of thousands of strikes, although it can happen during active periods. But the key is that if you have an ignition rate of 2 to 4 strikes per 100, all you really need is a few hundred strikes to get a fair number of new lightning ignitions, and that's within the territory of what we could certainly see this week. And another point that Mike points out is that some fires can smolder essentially in the surface or subsurface. So in the peat or in the root systems, if you're in a denser forest with a lot of organic matter. These are the so-called zombie fires that you may have heard about, and there have been a lot more of them in Canada and in some other parts in the world in recent years. These are essentially the overwintering fires. Sometimes they can even survive multiple feet of snow falling in winter and then re-emerging because the snow is pretty insulating. If it doesn't melt so quickly that it saturates the whole column deeply, if it slowly melts or ablates away in the wind, you can get those fires popping back up year after year. And we've seen that in Canada in recent years. We've seen some fires that appear to have overwintered now for up to 3 years. This very same fire popping up seasonally from that deep organic matter. It's not common, but it used to be exceptionally rare and now is apparently not all that rare. It's less common in California, but we've even seen some overwintering of fires in the Southern Sierra during the drought years, for example. Okay, well, with that, I think I'm going to leave it there. This was a bonus half an hour, so 90-minute holiday episode, at least an American holiday. And for those of you who joined a little bit late, I did offer a couple of links. Feel free to take the survey from University of California regarding my weather and climate communication activities. There's a link right at the beginning, and also a link to West Marin Community Radio, because at 5 p.m. today and again 5 p.m. tomorrow, 2 different episodes will air that we recorded last week, talking about a wide range of stuff that I think anybody who has just spent 90 minutes listening to me talk on Labor Day would probably be interested in those 2 episodes as well. So a link, preemptive link at the beginning of the session to that as well. That'll become available later today. Enjoy the warmth in California, even at the beaches today. Hopefully not too big of a lightning event tonight, but keep an eye out because it could happen. And hopefully there's no need for me to go live on short notice in the next couple of days, but I'll be keeping an eye on it via social media. And if things get really hairy out there, maybe I'll drop back in live as needed. So enjoy it out there. It's a very nice day in California. Fingers crossed we avoid a large number of lightning ignitions in the next 48 hours. All right,